Okay, I think we can start. I can see many people online with us today, which is great. So, welcome to Move Solutions webinar on static, dynamic, geotechnical and environmental monitoring, when and why. So the purpose of today's webinar is to explore the features and differences between static structural health monitoring, dynamic structural health monitoring, and geotechnical and environmental monitoring. So I am Andra Scotolati, and I work as a marketing strategist for Move Solutions. Here with me today, we also have Francesco, business development manager at Move Solutions, who will go into the details of the different types of monitoring. So today's agenda will be the following. We will obviously give you an overview of the different types of monitoring, explaining what information they provide about the structure, about its health and its behavior. And we are going to show when these types of monitoring are useful and when they're typically used. And you will also see some projects where Move Solution sensors and system were used to apply different types of monitoring techniques. Another thing that is important to mention when talking about structural health monitoring technology is the differences in data collection, and we will explain that too and why that matters. We will also show the different sensors for each type of monitoring. And since Move Solutions also has an online platform for remote structural monitoring, we will go through some of the data analysis tools that are important and used when it comes to the application of a type of monitoring or another. So, before going into the details of today's topic with Francesco, I would like to take a moment to reflect with you on why we monitor infrastructures and why it is so important. So these are these are some of the reasons, obviously not all of them. But for sure, structural health monitoring enables the early detection of potential structural issues, such as cracks, deformations, or stress concentrations. Additionally, when implementing structural health monitoring, the safety of infrastructure and of the people using it can be significantly improved, obviously. And in particular, remote monitoring of key parameters helps identify structural issues in time, and it enables our clients to act promptly in case of problems. Structural health monitoring also provides valuable insights into the actual behavior and condition of the structure, which helps optimize resource allocation. How? By focusing maintenance efforts on areas that require attention the most, usually with targeted and cost-effective interventions. Also, when using remote structural health monitoring technology and smart technology, another benefit is that on-site visits are drastically reduced, and that helps with resource allocation as well. Another benefit of structural health monitoring is that all information collected by the sensors about the behavior, the health, and the condition of a structure can be used for data-driven decisions, which improves maintenance strategies and infrastructure planning. Finally, structural health monitoring also plays a crucial role in ensuring compliance with regulatory standards and requirements. So these are just some of the reasons. Obviously, there are more, but what we can offer as a company that is focused on structural health monitoring techniques is also that we provide a system that is comprehensive because it integrates hardware and software services with innovative Internet of Things technology. What does that mean? It means that we offer wireless sensors for 4 different types of analysis: static, dynamic, geotechnical, and environmental. All our sensors are smart, small, plug and play, and very easy to install on the structure. Also, we offer and we provide our clients with a software as a service. In other words, an online platform developed with a user-centered design. That means that it's a platform that is user-friendly and straightforward for an easier monitoring experience. Finally, we also have data analysis tools designed to understand a wide range of structural behaviors. But what does that mean, this wide range of structural behaviors? It means that Move Solutions has developed specific solutions for different types of monitoring in order to analyze all the structural behavior that are important when it comes to assessing the stability and health of a certain structure. Behaviors that, for example, by just using static structural health monitoring would not be detected necessarily. So these types of monitoring are static structural health monitoring, dynamic, and technical and environmental monitoring. Static structural health monitoring has the longest history. It's the one most commonly used as well, and it has been widely adopted for monitoring infrastructure integrity and safety. On the other side, dynamic structural health monitoring gained prominence only recently, with advancements in sensors technology and a better understanding of the importance of the dynamic behavior of structures. Finally, geotechnical and environmental monitoring have become more important as means to assess and manage risks associated with external geotechnical and environmental factors, so with everything that surrounds a structure. And now I will leave the floor to Francesco, so he will go into the details of explaining how these different types of monitoring techniques work and why they differ from one another. To you, Francesco.
Thank you for the introduction, Ambra. And could you please make me co-host to share my screen?
Oh, sure. Sorry about that. Here it is.
Okay. Thank you very much. Just a second to share my screen and to begin the presentation. So, hi everybody, I think that lots of you already know me, but I'm Francesco. I'm a business development manager here at Move Solution and key account manager for the UK area and the Northern Europe. Thank you for your presence, thank you for your time, and thank you for following us on this interesting webinar. So, I will start from the static structural health monitoring with a little, let's say, overview about this type of monitoring and solution. The static structural health monitoring focuses on the long-term behavior of the structure. It is particularly useful for that kind of infrastructure that are subject to gradual load change over time. By implementing the static SHM, we can monitor and collect data over extended periods to assess trends and changes in the structural behavior and take timely corrective action before they maybe can escalate into much more significant problems. Through the static structural health monitoring, we can gather valuable information that help us to understand the condition of the structure. And this one includes monitoring parameters such as maybe as inclination, the rotation, or the static displacement. As you can see, a lot of the static structural health monitoring has a lot of application, and it is good for like most of the critical infrastructure like bridges, building, dams, and tunnels. Some application of static structural health monitoring that we are doing with our sensors are like the static monitoring of the Carriol House. That is a super interesting UK project in Newcastle that was carried out from our UK technical partner, Academy Geomatics. Academy Geomatics carry out this project where the Carriol House facade is considered to be a rich architectural heritage in UK, making the structural preservation of this building of utmost importance. While the rear of the building was demolished in order to make room for a new building to be built into the facade, sensors, so the tilt meters, were installed on the structure for continuous static monitoring of the facade of the building during these construction works. Another super interesting project that I would like to share with you is the static monitoring of the grain silos in Beirut from Amman engineer. The project conducted by the engineer Emmanuel Durant with the Move Solution sensor was like installing tilt meters on the silos that were damaged by the big explosion that occurred in the port of Beirut in 2020. We managed to let's say to check the safety and the integrity of that silos until the sensor starts to let's say to measure to get something was wrong. After the first alarm from our sensor, the place was totally cleared and secured. Firefighters were prevented from accessing the area and no one got injured when they really collapsed to the ground after something like 3 days from the first alarm. When we are talking about static structural health monitoring, we basically are talking about our triaxial tilt meter and triaxial tilt beam. The wireless triaxial tilt meter from Move Solution measures the inclination and the temperature of the point where it is installed relative to the gravitational axis. By installing a system that is composed of this sensor, it's possible to reconstruct totally the deformation of a structure. Of course, all our tilt meter, like all the other sensors, are battery powered. They work through the LoRaWAN wireless transmission and they can be perfectly synchronized with each other, making them perfect also for like static load test. Let's say in the end, the various acquisition method and schedule acquisition timing could be set remotely through our web platform, of course, by the end user. And then we have the triaxial tilt beam that consists of a series of tilt meters that are attached to a bar, which then is affixed to the structure to measure the degree of the slope or of the tilt over a larger area than a single tilt meter. Let's go a little deeper with some data analysis example. For example, in this video, you can find the overlays tool. The overlays tool allows you to superimpose data from different tilt sensors on the same graph in order for the end customer to be able to compare trends of the data of the structure in different positions, and therefore to visualize the variation and of the inclination over the time. This tool is super useful for structural monitoring of bridges, high buildings, towers, and all the structure that could be object of a static structural health monitoring, as this tool allows to evaluate of the distribution of the deformation in the structure and to identify of any critical areas in the structure. Then, going forward with the tools of the static SHM and the tilt meter, we have the cant and the twist, because Move Solutions offer also the full range of solution for the environment of the track geometry monitoring. This is an example of the railway tools with the cant and the twist tools. Cant, in the context of railways, refers to the transversal inclination or the difference in height between the two rails on a curved track, monitored with tilt meter installed on the sleepers. It is measured in millimeters and is an essential parameter in the railway engineer, as it plays a really crucial role in ensuring the safe and efficient operation on trains in curved tracks. Also, you can find the twist, that is the difference between two transversal levers measured separately at a predefined distance. And to calculate the twist, of course, is necessary to process the data collected by two consecutive tilt meters. Then, staying in the environment of the railway track geometry, we can offer also the vertical settlement tool. You can see in the video the graph that shows the deformation profile of the track on the vertical plane. Each point of the chart will correspond to the displacement values in millimeter provided by each sensor that forms the tilt beam change that is needed to get the vertical displacement of the railway track. And then, to conclude the examples of data analysis and data tools, we have the static deflection tool that allows you to evaluate the deformation of a structural element. For example, could be a beam or could be maybe the span of a bridge under the action of a static load. The tool uses finite element model to simulate the behavior of the structure and calculate the maximum deformation in the load zone. In this way, it is possible to evaluate, through the graph of course, the safety and the reliability of the structure, and to identify some critical points that can require some maintenance, action, repairs, or whatever. The static deflection tool is particularly useful for designers and engineers who needs to assess the strength and safety of the structure during the design phase. But it can also be used after in structural monitoring during the operation, with maybe the static load test with the cargo trucks on the span of the bridge. Now we can pass to the dynamic structural health monitoring, and with a little overview about what we mean for dynamic SHM. When we speak about dynamic structural health monitoring, we speak about a type of monitoring that is used to handle dynamic loading, such as people walking, wind, waves, traffic, huge blast, and maybe earthquakes, vibration. So this type of analysis is more suitable for that structures that are subject to fast impacts involving frequency, vibration, or dynamic displacement or acceleration. The dynamic monitoring involves continuous sampling, where sensors continuously measure the data, measure the environment, and then the information is stored when a peak of acceleration or vibration or displacement is detected. So, unlike the static SHM monitoring, the data is recorded here for a few seconds before, during, and after the peak of maybe vibration, resulting at the end in the collection of much more data than a static monitoring system. When we talk about dynamic structural health monitoring, we can talk about applications like high-rise buildings, bridges, stadium, wind turbines, and so on. All kind of infrastructure that are most likely subject of huge vibration, also at high frequencies. For the application, we would like to share with you these two case studies. The first one is a dynamic monitoring of an hospital after the huge earthquakes that occurred in the last period in Turkey. The project was carried out again from Emmanuel Durand, from a man engineer. And when the earthquake destroyed a very large number of buildings in Turkey, including this large public hospital, our devices provide key structural information on two remaining areas, one public and one private, of the hospital, helping in this moment the staff of the medical staff to be more confident, more eager to come back into the building and do their work, save life. The second case study from pictures 2 and 3 is a UK case study, still from our technical partner, Academy Geomatics. In this project, tilt sensors were used in the ventilation tunnel where a total station was not feasible. Each cross-section of the tunnel was, of the 28-meter long ventilation tunnel, had like three tilt sensors to detect any kind of deformation that was influenced by the construction site nearby. Then accelerometer and accelerometer sensor were installed at both ends of the ventilation tunnel to perform the modal analysis of the structure. Two accelerometers and a vibrometer were installed then in the running tunnel and the ventilation tunnel to enable all the part of dynamic monitoring. This project is super helpful to understand, of course, another key aspect about our solution, that of course the static monitoring does not exclude the dynamic monitoring as well. So they can be carried out at the same time, and different sensor on the same web platform will give you different insight on your project. Insight that may be from the static deflection, from the tilt meters, and another insight that can come by from the vibrometers and the accelerometer regarding the high frequency event and the dynamic part. When we talk about dynamic structural health monitoring, of course, we are talking about the DEX sensor, the accelerometer, SHM, and the vibrometer. The DEC is our patented sensor, unique in the market, that can measure the dynamic displacement of a surface, the amplitude of the dynamic of the displacement in millimeter of a surface over the time. The accelerometer is a triaxial device that can get the acceleration of an event in milli-G and the frequencies of that event on the 3 axes. And it can be synchronized to the other accelerometer that can be placed on site in order to perform the modal analysis study on the infrastructure. This very advanced feature is object of another patent from Mood Solution. Then we have the vibrometer, another triaxial device that is used to provide complete analysis of the speed, the frequencies, and the amplitude of the vibration, to comply maybe with some national regulation that can occur a lot of times in the construction site environment. Let's go to see together some data analysis example for the dynamic part. We have the dynamic displacement time response and frequencies response. This is the one that we call like the raw data from the DEX sensor. This graph is related to the trend of a specific vibration that you can find on the event column on the right side on the page, detected by the selected DEX sensor on our platform. Each event is described in a 30-second sampling, and the oscillation is detected by the sensor in millimeters. Also, below in the same page, you can view the fast Fourier transform algorithms that is used to calculate the frequencies response faster and allows to highlight the spectral content of the signal coming from the sensor. Then, still talking about the DEX sensor, we have the page related to the trend. The trend page allows the end customer to view and analyze data trends from dynamic sensor installed on a structure. In particular, this page allows the user to overlap the trends from different DEX on the same project, comparing the data of different physical quantity also. For example, the dynamic displacement that was measured by the DEC and the temperature trend in time, and to identify like any correlation between this different kind of measure. The trends relating to the number of transmission made by the various sensor day by day are also provided, so as to be able to monitor the state of health of the same and plan any preventive maintenance activities. Then we have the FDD, so the model analysis part. Model frequency tracking is able to automatically monitor the variation of the vibrational modes over time. So from the accelerometric or from the displacement data, it's possible to extrapolate the daily frequencies and the model shape using the FDD, the frequency domain decomposition technique. Then the frequencies are highlighted over time for each axis, allowing the end customer to distinguish the natural frequencies of the structure from the others that could be outlier or spurious frequencies. So it's like catching the natural frequencies of a structure, track down like a pattern and see if this pattern comes back to the beginning from where it started. If it's not, maybe something is happening, something that could be the normal aging of the structure or something that could need some action and maintenance. Then returning to like raw data, we have the raw data from the accelerometer, same thing as the deck before. Each event on the right column corresponds to a detected vibration from our sensor. Each event that the device measures is then represented by 3 graphs that describe the acceleration in milli-G for each axis. Also, we have the fast Fourier transform as well for the raw data and for each measure from the accelerometer. Then, to pass to the vibrational part, to the vibrometer, we have the PPV, the vibration analysis of the peak particle velocity of the vibrometer. The PPV is a measure of the maximum 3-dimensional vibration velocity detected by the vibrometer sensors. So the PPV is measured in millimeter over seconds and provides information about the magnitude of the vibration that is detected on the structure from our vibrometer. And then we have the PCPV, so the peak component particle velocity on a frequency scatter plot. That is a graphical representation of data collected by 3 axes of the sensor during a selected time interval. Each amplitude frequencies pair is compared to the alarm threshold selected by the user to establish whether an alarm is triggered or not. The scatter plot provides then a visual representation of the data and can help to identify patterns in the data by comparing the amplitude and the frequencies for each individual component within the selected period time. As you can see, it's very easy to read. So we will have the group of frequencies under the threshold in green, blue and purple, as you can see from the video, and then each one of the vibrations that are detected from the instrument that are exceeding the threshold will be displayed on the graph as red, giving not only all the data about the single vibration that is exceeding the threshold, but giving also the alarm to the end customers that something is going on maybe in his construction site. Then we can conclude talking about the geotechnical and environmental monitoring. For geotechnical and environmental monitoring, we refer to the process of monitoring and measuring environmental factors that can impact the stability of a structure or the stability of a site, such may be soil movement, groundwater levels, and changes in the soil's chemical composition. By monitoring these environmental factors, is it possible to detect any changes or anomalies that could possibly indicate issues or hazards, allowing for the end customer, for the client, to implement proactive intervention and prevent structural damage or failures. This kind of monitoring, of course, is often used in conjunction with static and or dynamic SHM monitoring to provide a full comprehensive understanding of the health and the stability of the structure overall. The most common application, the most common environment when this type of monitoring is used are like tunnels, embankments, mining sites, coastal area, and similar. Application, we can talk about these two interesting projects from two of the UK technical partners of Move Solution. We have a water level monitoring that was carried out in Hesworth, Whitby, from Academy Geomatics in August 2022. In the 2022 were concerns that the quay wall might have been moving, and the monitoring was aiming to verifying the movement of the quay wall. So Academy Geomatics and the director Mark Anderson proposed a system of 16 tilt sensor and 4 vibrometers as a better way of monitoring the quay wall, considering that the area the council was most concerned about was permanently obscured by a floating dry dock. It was also installed then an ultrasonic water level that was wired to an Move Solutions analog node to receive information about water level and verify whether the movements of the quay wall were due to that or maybe to the temperature. Another brilliant project from England, and this one is from Terra Measurement, another UK partner, is this ground deformation monitoring project that you can see in the picture number 2. In this project, thanks to a super smart usage of our tilt meters, Terra Measurement and his director Andy Bresley were able to install them on a railway embankment, as you can see from the photos, to check the stabilities and the stiffness of the embankment itself, checking and improving the safety of the railway track nearby. What are the sensors that we are talking about when we are talking of geotechnical and environmental monitoring? We are talking about the tilt meter and our nodes that are the single channel node and the analog node. For this topic, we will focus on our node device, since we already talked about the tilt meter, of course. We have the analog node, that is a device that enables all connected sensors that are originally wired for wireless LoRaWAN communication. The analog node is compatible with most of the analog interfaces used for geotechnical sensor, and once the geotechnical sensor is connected to the analog node and the gateway is correctly installed on site, they are ready to receive, store, and send the data. It's perfect for implementing any monitoring system and meeting all project requirements in terms of geotechnical probes operation. But better products, we have the single channel node, that is the latest device from Move Solutions. Single channel node will power up the geotechnical probe that will be plugged inside, will make the probe connected to our system through the LoRaWAN wireless communication protocol. And then it has like two very useful features, because each single channel node will support the NTC when it's present, of course, probe internals temperature measurement. And another very important feature of the single channel node is the possibility to unblock a functionality of accelerometer trigger acquisition mode of your third-party probe, because the single channel node comes with an accelerometer inside, and from the platform the end customer can set an acceleration threshold. Then when it's exceeded, will tell, let's say, the single channel node to power up the geotechnical probe wired to it and start reading the measure. The single channel node could be used for various kind of application. It is compatible with the piezometers for the water pressures and changes in the groundwater, crack meters to check the cracks of a building, maybe to assess its stability, strain gauge for the metal deformation, and many more, of course. The single channel node has a lot of readable interfaces for the third-party probes that you might need to connect to it, like NTC for 20 milliampere, millivolt over volt, 5 volt, 12 volt, vibrating wire, PT100, PT1000, and the potentiometer. As for the data analysis examples, we have the tool to read the geotechnical probes. As you can see from the graph, you can set in, you will set on the, you will set the unit of measure of the geotechnical probe, and then you will see the trend of the measure from your probe in time. Then you will get not only the schedule acquisition data, that is the one on the graph that is in blue, but you will also get the, in red, of course, the that values that occurred after the trigger threshold, the trigger threshold is exceeded. So you will see also on the graph the difference between the schedule acquisition data and accelerometer trigger threshold data. So I leave the floor to Ambra for the conclusions, and thank you very much for your attention.
I was muted. Thank you so much, Francesco, for your presentation. It was really interesting. I think it's very interesting to see how much structural health monitoring has changed, and it's changing, and it will be changing because and thanks to technology. And so thank you for that, for showing us the combination of software and hardware and data analysis tools for a more comprehensive approach to structural analysis. So what we can say now, we have understood that combining different techniques and different types of monitoring can give us a more comprehensive evaluation of infrastructure, which means early detection of issues, maintenance and repair, better maintenance and repair planning, better safety and risk management, better long-term performance assessment, and better compliance to regulatory that we have in each country. So it's I think we talk about smart cities a lot, and it's a very important topic right now. And I believe that structural health monitoring, for how it's developing right now, can really contribute to that. And I think it's exciting. So for any questions you might have or doubts, you can contact us at info@movesolutions.it, or you can check our website www.movesolutions.it, or you can contact Francesco directly. The recording of this video will be sent to you via email, and you will receive all additional information you might need to contact us. Also, we organize monthly webinars. So if you want to subscribe to our newsletter, you will be kept updated. We also have interesting articles that we release on a regular basis. So feel free to scan this QR code, or to check our website. There will be a right top button on our homepage to subscribe to our newsletter. And finally, you can follow us on our social media. We have Instagram, Facebook, and YouTube. On YouTube, you will find all our past webinars as well. So go and have a look if you want. The webinar is ending here. I can see a few questions popping out. We will be answering to the questions directly to your mailbox. So you will receive our answer very soon. And thank you for joining us today. I think it's been a very interesting webinar. Thank you, Francesco, for your presentation.
Thank you, Ambra, and thank you everybody for your attention.
Thank you.